Before I get into how Manhattan College is using Firebase to develop its student mobile app, I'd like to provide some background on Manhattan College and how its cloud journey has been evolving over the past decade. A lot of things have happened over the college that it was very important to share, but it allowed us to evolve our journey here. The Glance Manhattan College Student App was a big opportunity for change here. Before we get into talking about, though, I'll share some background of our cloud adoption. I'll talk about how it influenced web development at Manhattan College. And then another thing, we also were talking about how we evolved the app and what led to how we picked a native app. I'll then get into talking a little bit about Google Assistant, which was the idea of a personal assistant was always near and dear to our hearts. It was part of the visioning of the native app, but that's allowed us to use more of the Google Cloud product. And I'll touch a little bit on how we're using Data Studio, using data from the app in conjunction with BigQuery. We'll then follow with question and answers. Manhattan College has the best of both worlds. It's a residential campus. It's pretty tiny. It has about 4,000 students, 6 schools, School of Arts, Liberal Arts, School of Education and Health, School of Business. Those are located on the upper campus along with part of the School of Science. And down below, sure on this map here, is lower campus, and that houses the School of Engineering, part of the School of Science, and also the Research and Learning Center where my group and most of IT is located. You notice that it's very close to Manhattan. There's actually the end of the subway line is just to the east of the campus. So there's 2 subway stops right down there, and it's about a 35-minute ride into Manhattan. So it's very close. And even Manhattan is pretty small. Manhattan College is small. I work in the lower campus. It's about 4/10 of a mile walk up to the entrance to the college. It probably takes about 10 minutes. So it's sort of densely packed. There's been a lot of changes that have happened over the college over the last 10 years that are sort of relevant to our cloud journey. There have been changes to the physical infrastructure. The college converted from mostly a commuter campus to a residential one, probably around 2012, with the addition of more dormitories. And there's been a lot of master planning going on. The most recent one was the addition of a, pointer, was the building of a student commons in 2014. And with the introduction of that, there were a lot of other things that had happened in the college in terms of branding. We also got a new president around 2009, also some new people, and that's when a lot of things started changing, including our adoption with cloud.
Overlooks the Hudson River.
Oops. Sorry. I'm going to describe a little bit about the group that I work in. Manhattan College is, of course, a higher education place. Our information technology services department is structured similar to like in other colleges. I noticed that there were a number of people here at this presentation from higher ed. So we're part of information technology services, which is headed by our CIO, Jay Comquist, who's here today. We also have 4 groups, of which mine is one. My group is Web Applications. It was formerly called Web and Collaboration. A lot of these names have changed a little bit over time. We have Enterprise Architecture, and they're responsible for security, networking, and what used to be the data center. And we have a director here, Rob Moran. We have Enterprise Application Group, which is really responsible for our ERP system, our enterprise resource planning system, and all our business applications. We have Client Services and Operations, which handles our help desk. and also knowledge base, service catalog, and operations are all public labs. And then my group, which is involved in anything related to web pretty much, it changes over time. The whole IT organization is like 22 full-time people, so it's pretty small, but everybody has to wear a lot of different hats. And so we work pretty closely, my group works very closely with most of the other groups. In addition, because we are involved in the web, we work very closely with marketing and communication, in particular now the Office of Web Communications. Now, Manhattan College, I need to mention here that Manhattan College received a 2017 Cloud Leadership Award from E&I Cooperative Services. It was presented at the EDUCAUSE conference in Pittsburgh or Philadelphia last fall, and they got this for their involvement in advancing hybrid infrastructure and platform as service cloud architectures. So our Information Technology Services has done a lot in terms of using cloud, and in particular Google Cloud. A little bit about my group. We're basically a development group. Right now we have 4 people. We used to have 3 people. Again, we're involved in all things web. About 20 years ago when the web started, we were involved in a lot of things. And about 10 years or so ago, marketing and communications took more of a role in that, and web group in IT took more of a support role. We also work a lot with emerging technologies and trying out new things and trying to use them to develop custom applications. Because of the type of materials we worked with, we've sort of been adopting an agile and DevOps culture in cloud computing. We use a lot of open source software. I always laugh because we sort of have a frugal mindset, because a lot of the things that my group does eventually gets replaced by a product that comes out. And so a lot of the stuff that we're doing, we feel like we're throwing it away all the time. So whenever we do things, we try to develop our things for reuse. And that's a good thing now, because now with APIs and everything, it sort of all fits into the model. Now I'm going to talk about Manhattan's journey in the decade of the cloud, decade of mobile, and the whole approach. I've been at Manhattan College for like 20 years, and for the first 10, we basically started the web and everything. It seemed like not much was happening. We were in the era of Web 1.0. You had your web server, people did stuff, whatever. And then about 10 years ago, Web 2.0 started to come into play, and everything became more collaborative. People started contributing information and things. But that was also, I think, when a lot of this, everything as a service started. We started to see a lot of software as a service being introduced. The first one in that case would be Gmail. Okay, and eventually, but most of those things are all services that are delivered over the internet rather than provided locally or on site. So this thing has been growing over the past 10 years, or evolving. Today, especially in higher ed, we're seeing a lot of adopting of best-of-breed applications. So rather than having everything from one vendor, we're adopting a bunch of products from a lot of different vendors. And that presents a lot of integration challenges. So the role that we play is quite different. So here's sort of a simplified timeline of Manhattan College and its involvement with Google Cloud. And again, I concentrate on the last 10 years because that's when we started using our first software as a service, and that was Gmail. That was pretty revolutionary at the time. We were probably one of the first sets of colleges to introduce that. That was part of the G Suite, formerly called Google Apps for Education. And so we started using a lot of Google products: Calendar, Docs, Forms, Sheets. In addition, we've always used for web the Google Search, Google Maps, Google Analytics. Another big thing that we've sort of more recently adopted was across the campus was Google Drive. But rather than the last 10 years, I think the key defining point for the college in terms of moving to the cloud was in the time frame of 2014 to 2016, There were a lot of things that happened in the college that just sort of gave us opportunities to do this. Was basically what we call Google Cloud Phase 1, when Rob's group, the Enterprise Architecture Group, introduced a virtual machine as a service. So what that entailed was migrating a lot of the web applications over to Google Cloud and to the compute platform. And also at that time, the college was going through a rebranding effort for their websites. And part of that involved us providing web servers. And rather than hosting them in our data center, they were now hosted in the cloud, on Google Cloud. So that was with also high availability, load balancing. That was a big success for us. Eventually, that evolved more into Google Cloud Phase 2, what we term the hybrid data center, where the database was left in our data center, and the other parts of the system were out in the Google Cloud. And that was facilitated by the introduction of site-to-site VPN between the data center and the cloud. So now we actually had two parts of the system running in different places, but connected. And so we had our first launch of our enterprise resource planning system in the cloud in around 2017. So our CIO was very, very into cloud and advancing cloud, and we had a cloud-first strategy became part of our annual goals starting in 2016 and 2017. Part of we were told basically no more servers. Everything that we get now, any kind of service is deployed in the cloud, no new hardware. So that's sort of been the mandate. It's been a little tough to handle from the beginning, but it's all okay now. But everything has been working well, and we've been pretty successful. Oops. What happened here? Okay. So I'm going to talk a little bit about the web technology landscape prior to 2014 and how we used to develop our applications and whatever. We were pretty comfortable and used a PHP-based LAMP stack, which was Linux as the operating system, Apache HTTP server as a web server, MySQL as a relational database, and PHP as the scripting language. And that was used for most of our custom development work, but also to run our website, which we were using open source Drupal as our content management system framework. We eventually we used to self-host that, and eventually we started moving that to a platform as a service provider in 2014, 2016. So we got some experience with the cloud from that. That was a little tough. On the other end, we had what we called My MC Portal. And I don't know if some of you are younger, you might when you were in college, you might recall the portals that your school used to have. It was basically almost like a monolithic system of little screen windows into a bunch of different applications. A lot of it was connected by single sign-on. That was pretty difficult for us to pull off. First of all, we adopted a open source framework for that called uPortal. But that was a Java-based stack. It used Linux as the operating system, but it used Apache Tomcat as the web server and Oracle database, a relational database for database, and then it used Java. So we only have a small staff. We had 3 people in it, and only like one of them was a really good developer. So we learned a lot doing that. We ran that for about 3 years, but it was pretty limited. And in the end, marketing and communication was looking for something more of like people can go in and have a WYSIWYG editor and enter content, whatever. So eventually, as part of the web branding initiative, we got rid of that and moved to something different. Oops. So again, a lot of things happened in 2014 to 2016, and I just say this was sort of a defining period for us, and especially for the web. And was it fate? Was it kismet? Was it serendipity? Everything just sort of came together very nicely. Everything was happening at the right time. The college was going through a branding initiative for the websites. in which case we ended up with a vendor-hosted content management system. There were also a lot of campus master planning taking effect. The college had, you recall that I showed the new student commons. With all that, they finally licensed a room event scheduling system. So now we had a lot of calendars and stuff. And all this, everything as a service was maturing. And the best part for us and for our adoption of Firebase was we got summer interns. The college had a Jasper summer research program, and prior to that, a lot of other departments, especially in science and engineering, were hiring students to come up with a project they wanted to work on, and they would fund it for the summer and whatever. So ITS took on, well, my group took on 2 summer interns, and we had to come up with a project for them to do. So before I get into the start of Firebase and how we use that, we're seeing a lot of shift in technologies and development at this time. Our content management system and the publishing model was different. The websites were all developed through a vendor SaaS solution. But what was happening here is the web content from that system was basically published out to web servers, sort of like a static website. Okay, it had hooks in to use feeds and widgets and things like that, but a lot of the stuff, even with PHP, was basically done behind the scenes, and the website was published out every night, republished out every night. So that gave us more opportunity to start working with data integration via widgets and feeds, and either in RSS XML format, or more importantly, the JSON format, which we've sort of adopted, and it's also part of how Firebase works. On the other end, it was like the death of our portal. I don't know if that was good or bad. In retrospect, it was good, but we still sort of a little sad to see a lot of that go and a lot of the work we had done disappear. There were certain parts of the portal that were useful, and one of the things was what they had was you were able to search within a portlet, and portlet is basically one of those windows, whatever, but you basically would enter some metadata about what was in the portlet, and a lot of that was used at the portal level to help people find things. Another thing that the portal always had was a lot of quick links. You were starting to see a lot of these everything as a service products out there, and people were using the portal as a place where people would come and find all those different links. So it was basically just a list of links. But anyway, for the searching, people were starting to see more, looking at other kinds of solutions, because the portal and pulling it off was a very difficult concept unless you really licensed a version from one of the big vendors. But you're starting to see more lightweight campus portals where people were starting to say, these other products do their thing well. They don't really want, like for example, Google, they don't really want you pulling in your email threads into a window in the portal, and pulling in your calendar stuff into another window of the portal, and pulling in your files and looking at them in another one. And basically it had its own interface, and so roll with the flow. So, but those are some of the good features of the portal that people like to keep. And again, it was a big learning experience for us. It was an open source product. We learned a lot about developing code and contributing code, whatever. So a big thing for the new, what they called an internet website, was a way of aggregating all these campus tests and services. And to do that, and this is also happening in conjunction at the same time that we started developing a student app, was a way to aggregate these someplace so that people could find the information. And the approach we basically took was, defining things like pay my bill, things like that. And it might be embedded in some system, but people would search for, pay my bill, or tuition, or whatever, or find the final exam schedule. And they would find it through this interface. And for this, we used a search as a service product from Algolia. So now we get into developing the Glance MC Student App, and it was sort of named like that because of how some of the conditions we put on this development. So again, our native mobile app was a summer of 2015 student project. The students had to come up with a project. They started one day, I came back from vacation, say, here's your 2 students, it's like, they need a project. And so at that time, everybody wanted to develop apps. Okay, well, they came up with there's this word cloud here, and things that were hot at the time were mobile, discovery, portal, lightweight, digital, search, native, personal assistant. The big thing was the campus ID card. Okay, what we call our Jasper card. Manhattan College, I didn't mention this, are the Jaspers. So I'll keep using the ID card and Jasper card together. But students basically carried their phones around all the time. A lot of times they were forgetting their paper ID card. Okay, with all the new buildings that were happening, they were starting to use these optical scanners to allow entry into the dorms and to the athletic, the gym, and other places like that. So the students kept saying, oh, it'd be cool if we had our ID card on our phones. So all that was part of the visioning for this student app. So then we had a choice, okay. What are we going to use for the stack to develop this app? At the time, you really had Apple, you had Android, or we could develop a cross-platform app. There were, at the time, a predominance of Apple devices on our campus. Students might have had a phone, the ecosystem from Apple. It could have been like the laptop, they had a phone, they had an iPad, or whatever. And the students wanted to develop apps for Apple and felt that development was easier there because they only had a couple different sizes. You had a couple different devices, and they were all the same. Okay, so when you looked at Android, you had a lot of different phones you had to worry about. Okay, plus the students that we had were also just going into their junior year. They really hadn't had any, the college really didn't have a computer science program at the time. The students didn't have any kind of training or anything, but they just felt comfortable developing for Apple. And they had, I guess Swift had just come out, whatever. For Android, they had Android Studio, whatever. And it wasn't that well documented at the time, or the students felt. So the other choice was a cross-platform app, and they really couldn't get their hands around that, and the whole idea of thinking about that was tough. So who do you think won? First app was an iOS app. Okay? Under the condition that the next one would be Android. So we had these 2 students working all summer. They were funded as a Jasper research scholar at the time. We've employed them during the school years using campus employment work-study funds. And we also allowed them to learn. We provide a lot of training. There's a lot of self-study, self-learning that goes on in my group. We have a lot of resources for that. But anyway, they ended up with conceiving a lightweight mobile app, and they wanted something where they can access information on the go. One of the conditions for marketing and communication was that it complemented the new websites that were coming out. And the college did not have its own mobile app and didn't see a need for one. The websites were all responsive, and they felt that was good enough. But part of our justification for using a native mobile app was that we would use the features of the device, like maps and locations, and also that we have a digital campus ID card for use with optical scanners. Okay, and so the way we worked it was, this was kept as a student developer product. My group had oversight, and it sort of evolved a lot into some healthy competition between the 2 groups, where we learned a lot from what they were doing. We also sort of vet what they're doing and make sure they're on the right track, but there's a lot of competition. So now I'm going to get into developing the Glance Student App and our app basics, or data modeling. So the first thing they had to do to come up with what they wanted to put in is collect all the data. And we need to have some place where they could collect it, where we could see it. So the the database quote for that was basically a Google Sheet. Okay, so they collected all the information in a Google Sheet. A lot of it was like maps information, coordinates, building codes, the addresses, things like that. This is a little bit more sophisticated than what they had at the point, but they had a lot of the stuff we had from the portal were feeds, daily announcements, news, Twitter, features, events, events calendars, lots of events calendars with the new system they had just put in place. And so they collected all in a Google Sheet. And then they used this data when they started developing the app. So when the app was released, they basically wrote all the stuff into the code. Okay, we released it a year later, year and 3 months later, called Glance MC, because Glance meaning that we really didn't want them to incorporate things in there that would get replaced by an app that came out in the future. For example, if our ERP vendor came up with something and this college adopted it, we didn't want to have to sort of throw away what we did. So they were supposed to keep more to, top level type stuff here. So we released it, and at the same time we released Jasper Pay at the college, which allowed people to pay for their meals and stuff using their digital ID card, and that's become a big hit. We also employed in there this, what we call the at-a-glance search, which was part of the aggregated campus services that we show that we use on our internet portal. And we have a employee directory and all those services in it. And we also incorporated a bunch of RSS and XML feeds and a campus newspaper. With time, we've added in geolocation, maps integration, so that someone could see if they looked up an employee, it would tell them if they clicked the location icon, it would show their location on a map and where they were relative to the place where the person was located. Same thing for the calendar. If the event was happening someplace, you'd see where it was. Part of the problem with all that too is we couldn't really use directions because our campus is not mapped out by Google. You notice there's a ring road that runs around the campus on Upper Campus with all these buildings contained within. So here comes the turning point now. We've released this app for iOS, and now we had to worry about Android. Okay, so we wanted to match the features from the iOS app to the Android one. And then for further development of the iOS app, there's a lot of things they want to incorporate, like favorites. Once they found things that they like to search, they'd like to pin them so that they have access to them all the time, their own favorites. They wanted to have an in-app campus ID card. Okay, so the way we deployed the campus ID card was through Apple Wallet, and we actually are using a PKPass file to do that, which my group had set up. Eventually, when we released this app for Android, they coupled it with I think it was called a Wallet Passes thing from Android, so they could get the campus ID card. But if we had an in-app gesture card, then people didn't need the other application. Eventually, we want to have access to authorized data via authentication. Like people wanted to see their course schedule on the phone. We still had a lot of commuters or people that lived off campus, and a lot of times if they wanted to go to our student information system, they have to go through a lot of different steps to get to their schedule, and it was a format they couldn't read on the phone. Okay, so part of the problem with all this now was the app data is actually on the device. It was really difficult to get something released into the Apple Store. It was a long process. And plus, anytime we wanted to change things, there were things that were always coming in. Somebody would say, can you incorporate this? We'd change calendars, we'd change fees, we'd do whatever. And so that was an issue. And so we sort of saw the need for a mobile backend as a service for this. And part of the whole thing was this app development takes a lot of time. So part of our agile methodology, let's rethink it and see what we need to do next. The other choice was also, should we switch to something like React Native to develop a cross-platform app? So now, developing the app, take two, enter Firebase. So the concept that students had at the time was to use Parse as a mobile backend, and then that was announced that they were getting rid of that. But a good thing was Firebase was acquired by Google in October of 2014. So that was the thing we looked into. And the first step was to remove the data from the app so that we could share it across app versions. So here's where we have the model for Firebase. And At the time, there was Firebase RealTime Database, where you could access the same database from an iOS or an Android device and also via the web. Okay, and the data gets synced in real time. So how do you think we propagated our Firebase RealTime Database? We go back to our original Google Sheet, okay, and they're just, so they wrote a little F script to take the data from the spreadsheet and upload it to Firebase. Okay, and that's an example of just sending the data from the little excerpt on the left of code is just what it takes to send something from one sheet to the other. If somebody goes in now and changes something, they added a new thing, it's real time, it shows up in the app and it syncs over to Firebase. And so this is a little screenshot of our Firebase real-time database. The Firebase real-time database is a NoSQL database, which means it's not structured like in tables like relational databases are. But the big thing now is all the app data is in the cloud. Okay, and this is a more recent version, but you'll see here some of the things that we have in here. Campus alerts. We actually have tutorials for there that refer to pictures out in the cloud someplace. We have our building calendars, feeds, tutorials, and then eventually users because we incorporated favorites going on, so it gets a little more complicated. And it was actually pretty easy to set all this up. So that was a big hit, a big reason to use Firebase too. So after that, we started using more of the Firebase ecosystem. The key one here was Firebase Authentication, where people can sign in by their Manhattan College or Google email address and password. That facilitated the development of an in-app campus ID card and allowed people to pin their favorites, and showed an example of the ID card here. It basically just has a barcode, whatever, and also there's a place where people could add funds to their account. Actually has a picture and all that. So people were using this now to swipe into dorms. When they swiped in, the person on the other end would see a picture of the student from our database in the college, and to identify the person. And also they were using it to pay for their meals and other things. And it gives them their balance and whatever. It's pretty immediate when it gets updated. And also here's the thing where they can favorite their employees and also their favorite services from the Algolia search. Another part of the Firebase ecosystem we started adopting was Cloud Firestore, and that was in beta. Okay, and that was a little different model for how the data is stored. Part of the problem with using the real-time database was it only allowed you to use string type of data. And if you want something more structured, the programmers had to write a lot to be able to work with that. So Cloud Firestore, again, is a NoSQL database, but it's a lot more sophisticated and allows for more types of data. And the use case for that was a quick view of a student's semester schedule with an integrated map and instructor directory. Okay, and here we have when they released a screenshot where they released my courses for the spring, and it actually shows a student's schedule. Over here, they haven't yet linked it to the faculty member's profile and also the building directory. So the Firebase document collection for the Cloud Firestore is basically consists of a collection with documents. So the way they have it set up is you have a collection of students. So each one of these would be a student. A student would have a bunch of information organized by term. First of all, we started doing it for one term, and that's how we initially released it. But the students can register for the next semester at a certain time, and they'd like to see their schedule on their phones. It was hard to just display the current semester, and they really needed a range of semesters and all that. So it's organized by term, and each term would have, a student would have a bunch of classes, okay? So that's how that's structured. A lot went into the thinking as to how they wanted to organize this. And the good part was, because we have an iOS developer and an Apple developer, the two of them sort of vet things out amongst themselves and eventually choose the right way to approach it. And this sort of shows, it's hard to show, I was going to show this on a timeline, but like how the app was developed over time. We started out for iOS, and eventually, we started with the Android one and sort of played a little bit of catch up. But because of how we adopted Firebase in it, we didn't have it at the beginning. The people doing the iOS development had to go and refactor a lot of the code and start over again because they ripped stuff out, whatever. The Android person started out fresh with Firebase and all the products, and it's been a very quick evolution for that. And actually, he's probably ahead of the iOS person right now. Okay, so part of the features we used were, we used the RealTime Database for basic app data. We used authentication for the Jasper card and also for favorites, and then Cloud Firestore for the course schedule. There's a bunch of other ecosystem tools in Firebase for stability. We have Crash Analytics, crash reporting, and they also have Firebase Test Lab, which we used. It also has built-in analytics, Google Analytics for Firebase. Rather than show a demo, I'm just going to do a quickie overview, a promotional video of the app. It's sort of quick. But we've introduced this for orientation back in June. So get students into using the app and their ID card. Okay, so sort of a lot of this sort of affected where we're going with web and web applications today. We sort of see a lot of this thing as an app convergence journey where we'd like to sort of get these two native apps into sort of one in some way. We're looking at maybe the Firebase cloud functions into helping us do that. We've also started to develop a lot of web apps, and it's a lot quicker to develop that way, and we've been incorporating them into here by just a set of links. Our web application development stack has changed quite a bit as a result of mostly how we were using Firebase, and it's a lot different today. We're using a lot of APIs, different kinds of libraries and stuff, and even being able to run on Node.js on the Google App Stack. So I went through some of this. We've also taken some of these concepts and have experimented with a bunch of Google Assistant actions. The most recent one is Talk to Manhattan College. And there's a way to extend the assistant and use the dialog flow conversational action piece to leverage the data from Firebase and the app. I'm running out of time here, so I won't show this little demo. Again, we're using analytics via BigQuery and Data Studio to look at some of the information from the app. So this is a segue into actually learning more about how we would use Cloud SQL to analyze and bring together other data sets from the college on a higher level. So in conclusion, the Firebase platform has been a great entry point for integrating with other Google Cloud tools, and they've been a valuable partner in our continual cloud journey. The best part was it was a way for us all to learn how to develop with the newest tools. Okay, thank you. Now.